2:06 in die aand gevier. Dit verwys na Afrikaanse getal 6,02 × 10 tot die mag 23, wat die aantal deeltjies soos atome of molekules in 1 mol van 'n stof aandui. Hierdie wetenskaplike dag word gevier om chemie meer toeganklik en interessant te maak en om mense bewus te maak van die belangrikheid van hierdie konstante in die studie van chemie. Die datum en tyd is simbolies gebaseer op die waarde van Afrikaanse getal.
Dan wil ek wel graag 'n spesiale verwelkoming doen, the Nuttiest Professor. He's a chemistry lab technician at a wonderful and awesome organization called SciBono. Dit is soos 'n kombinasie van woorde, sci vir science en Bono is 'n wennawoord vir vision. He has a national diploma in extraction metallurgy. He used to be a metallurgist, but he has swapped that to become an educator. In his spare time, he loves to watch documentaries and anything related to science. One of his hobbies is reading and cooking, so today he will be cooking something extra special, chemistry style. Thank you.
Thank you very much for that introduction. Good morning, guys.
Good morning.
How are you guys? Like they said, I am the Nuttiest Professor, and thank you very much for inviting me here for the whole day. Okay, but before I start, guys, a word of warning. Okay, some of the experiments that I've been doing, they'll be making a lot of pops and bangs. Okay, so if your ears are quite sensitive, you can just cover them up. Okay, don't put your fingers inside. Just use the palm of your hands. Okay, so I will start with something very, very simple. Okay, so here I've got a straw, and I will attempt to make music using a straw. Okay, so what I have to do is just blow through it, and I should be able to get sound, right? Can you hear that? Okay, some of you can hear it, some of you can't. Okay, I can barely hear it as well. So I need to do something. I need to adjust this straw so that I can be able to get some form of sound. Okay, so what I will do is I will create what looks like an arrow. Okay. Then I've got 2 flaps which I will flatten them out. So hopefully I'll be able to create some sound. I think my 4th teeth are not working. Okay, now let's see if I'll be able to create some sound. Just a little bit more. Making that sound. At the beginning we did not have sound, but now we sort of have that sound. What is creating? Okay? Because now I've created those flaps, okay? And when I blow air through those flaps, they are doing what? They're vibrating, okay? And that vibration is the one that causes sound. That's why when you put your 2 fingers here, and every time you speak, you can feel those vibrations, okay? So that's what is creating sound, okay? That was just an opener. But now, for you guys to see these demos that I'll be doing, I need to test your eyesight. Okay, because if your eyesight is not good, you might not be able to see some of these demos. Okay, so what I have here is I've got 4 empty cups. Okay, and I have some water as well. Okay, and to prove, guys, this is water, I will have a sip. Nice and refreshing. Okay. So I will choose 1 cup where I will pour in the water, then I will shuffle the cups around, and you need to tell me which cup has the water. So I'll just choose this one. So there's the water going in. Okay, now let us shuffle the cups around and tell me which cup has the water. Okay, so you need to keep your eye on the cup with the water. Okay, I'll try to be as fast as I can. So which cup has the water? This one. Are you sure? Okay. Are you a proton? That means are you positive? Okay, let's see. Okay, now there's 3 cups left. Which one has the water? This one. Okay. this one?
On the right.
On the right. This one. Or your right. Okay. So it's obviously this one. So guys, fish out for you. Okay? So what happened to the water, guys? What happened to the water? Obviously it cannot evaporate because it needs lots of energy for evaporation. And there's definitely no holes underneath the cups. And if there were holes, obviously the water was going to run down here. So what happened to the water? Hopefully no one is wearing this today. Okay? Maybe or a baby diaper. Okay? So before you came in here, I tried to put something inside. Okay? I put the innards of a baby diaper. So what is nice about this baby diaper is called a chemical called sodium polyacrylate. Okay? Sodium polyacrylate turns the water into a gel-like substance. So it prevents any leakages. Okay? So that's why companies like your Pampers, your Huggies, they say your baby can stay dry for longer because they know that sodium polyacrylate turns what? The water into a gel-like substance. Okay, speaking of water, guys, we know that water is very, very important. You know, water is life. And without water, none of us will be alive today. Okay, your plants need water, animals need water, and us, we need water. So what I did is I decided to go around out there, and as you know, we've got a water crisis. Besides the Moldag being below 40% now, we also have very unclean water. Okay, it's not well purified now like they used to. Okay, so which is really a concern. So I decided to go around various parts of Gauteng and decided to collect water there. Okay, so here I've got water from Johannesburg, water from Pretoria, water from the source, which is the van, and finally water from the West Rand. So I want to mix all this water together and let's see what I will get. But for this, guys, I will need 4 volunteers that will help me out. Okay? Come. And at least I need 1 lady. Okay? And we'll start with the roses. What's your name, ma'am? Alexi? Nico? Rikas? Maris. Okay? Can you stand in front so that the audience can see you? Then each one of you will have your own water. Okay? But before we start, safety first, guys. Okay. Okay, so stand there so that I can hand you out the water. Okay? So remember, this is water from where? Johannesburg. This is water from Pretoria. This is water from the van. And finally, water from. So now we want to mix all this water together. So we'll start with water from where? Johannesburg. Yes. Come and pour all of it. Now we'll go with water from where? Pretoria. Pour all of it. Okay? So now since like our water has turned into what looks like grape juice. Okay? Now let's take water from the source, which is where? The van. Okay? It's going back to being water. And finally, water from where? The West Rand. So we end up what look like milk. Okay? So thank you very much, guys. You can put down, clap hands for them. I will explain later what was happening here. But then, if you decide to drink all the water from all those places that I mentioned in Gauteng, you'll end up with milk inside your stomach. Okay? Continuing again with water, but now this is water from a different source. Okay? Now this is water from Saigon, but not anywhere in Saigon. From the toilets at Saigon. Okay? So this, I'm very disappointed. This is from the gentleman's toilet. Okay? It's not clean at all. Okay? Then we've got water from there. Ladies, nice and clean. And finally, water from the toilet also, but the tap. Okay? So we are going to mix again the water together. So again, I need 3 volunteers to help me out. Okay? We want to see what will happen. Yes, you can come here. 2 more. Okay, safety first, guys. What's your name, ma'am? Elaine? Tia? Tia. Okay? And Lincoln. Okay? So I'll each give you your own water. Okay? Water from the gentlemen, or boys, okay? The girls, and finally for our little angel, water from the tap. Okay? So we're going to do the same thing again. Mix all this water together. Okay? We'll start with water from the boys, or the gentlemen as they call it. Okay? Okay? Mix it with from the girls. Anything happening? Okay? Now let us just be careful there. Mix it with water from there. All of it. Anything happening? Okay. Okay. Thank you very much, guys. So sit down, just be careful there. Okay, inside water, this is how we make our soft drinks. Okay? This is how we make stony, water orange, and coke. Okay? That's what you could like coke. Okay? So guys, if you want to have a taste, after I'm done with the show, you can have a taste. Okay? So for the next one, guys, I want to see if it's possible. Yes? Does it? No, I actually add carbon dioxide. Remember? I haven't added the carbon dioxide yet. Okay? So guys, for the next one, I want to see if it's possible to crush a can without using your hands. You think it's possible? Using your mind. So I want someone with a strong mind to come and help me out with this one. Okay? Someone who can use their mind to actually do things. Anyone? Here comes sir. So I've got two cans, two very good cans here. So this one is for you. What's your name? Okay. Safety first. Okay. This can is for you. Now I want you to try and crush that can using your mind. Okay? So you look at it and say, can be crushed. You think it's possible? Okay? But I will try and do the same thing, but I will use what? Science. Okay? So to show that there's nothing inside the can, okay, well it's not really empty, there's air inside. Okay? So I'll just add a little bit of water. Okay? You can ask the audience to help you out to crush the can. Okay? Then I'll put my can here. Okay? So obviously I'm heating it up. And once I'm heating it up, what will happen to the water inside? It will start to boil and do what? Change from a liquid to a gas. So as soon as we start seeing steam, that means our can is ready. Okay, you can crush it any way you can. You can use your feet, you can use your head, you can use your hands. Okay? So it shows that sometimes it's not possible to crush a can using what? Mind power. Okay? So that's why we say inside Bono, we do not do magic at all. We only do what? Science. Because each and everything has an explanation. As soon as you cannot explain something, it means what? It means it is magic. Can you see what's coming out now? Okay, thank you very much. You can sit down. What's coming out now? Okay? This is steam. Okay? Steam is coming out. This is now water in a gaseous form. Okay? So what I will do is I will take my can and then see if I'll be able to crush it using science. Okay? So it is possible. Okay? So what happens there? Why did this get crushed? Okay? As soon as I added that little bit of water and started heating it up, the water vapor got to replace what? The air that was inside. So now that can is full of what? Of water vapor. But as soon as I put it inside my water, the water vapor cools down and goes back to being what? Water. So the air has been displaced. So now what do we have inside the can? We have what we call partial pressure or a partial vacuum. Okay? So that means the air outside, the pressure outside is greater than the air inside. Okay? So the air outside is trying to rush inside the can. But there is no opening around the can, and we obviously know the hole is inside the water. So the best thing that the air can do is to implode the can. Okay? So this is what happens because of the pressure. Okay? So now I'm getting to the exciting part. Okay? And this one, the reason why I'm saying it's exciting, because I know come the 31st of December, going into the 1st of January, we get to celebrate the New Year. And usually what do we do? Fireworks. Okay? So do you know how they get the colors of the fireworks? Okay? They use some of these chemicals. Okay? Here I've got what we call copper chloride. And I want to tell you what color does it make. Okay? Makes this nice blue color. Okay? Then I've got the next one, which we call strontium chloride. Okay? And tell me what color does it make. Okay? Makes this nice red color. Okay? So this is how actually they make your fireworks. And finally, I've got this metal, and I'm sure some of you know about it. Okay? This metal, you cannot put it out once it's on fire. You cannot use water or a fire extinguisher or a carbon dioxide fire extinguisher to put out the fire. Why not? Because this metal here, which we call magnesium, okay, it will rip off the oxygen from the carbon dioxide and from the water. And if it rips off from the water, it becomes a bit dangerous. Why? Don't look at it directly. Okay? So this one can also be used for fireworks, but also for what? For flares as well. Okay? So I asked you a question. What do you think you cannot use water to actually put out a magnesium fire? Yes, remember it rips the oxygen from where? From the water. And what will you be left with? And hydrogen is what? It's a highly flammable gas, so it might cause an explosion. Okay, so whatever you do, guys, if you know that the fire is a magnesium fire, do not use a carbon dioxide fire extinguisher. The fire will be more, and do not use water. Okay, rather use a chemical-based fire extinguisher. Okay. So what I like about chemistry, guys, is the different things that you can get. And sometimes you don't know if you can get a chemical reaction. Okay? Because how do you know you have a chemical reaction? You get your color change, you get a change in color. So color change, you get an increase in temperature or decrease in temperature. You get an explosion. Okay? And sometimes you form bubbles. Okay? So for the next one, I want to see if it's possible to freeze this beaker to this board. Okay, using a chemical reaction. But for that, guys, I will need 2 volunteers to help me out. Okay? 2 new volunteers, guys. Need 1 more? Okay. Okay, it's coming. What's your name, sir? Kelvin. Okay, this is the front. What's your name? Safety first. Reese. Okay, safety first, guys. Okay, like I said, I want to see if it's possible to freeze that beaker to my board. Okay, so here I've got a thermometer. So one of you will be staring, then one will read the display on the thermometer. Okay, again, my water, to prove it's water still. Like I said. Okay, so I'll just add a bit of water here. Okay. So can you tell them currently what's the temperature? Let us look at the audience.
16.9.
16.9. So it's actually measuring the temperature of what? Of this room here. No, don't put that, you have to stir it. Okay? So here I've got 2 chemicals. One is called barium oxide, and the other one is called ammonium chloride. Okay? So what I want you to do is stir this whole mixture, and every 5 seconds you read the temperature. Okay? Face the audience so that they can see it, so they can see you. Stir the mixture, stir vigorously. Okay? And tell us if the temperature is going up or down.
It's going down.
Okay, what's the temperature now?
11.1.
Okay. Again?
2.7.
Okay, again?
Minus 4.4.
Again?
Minus 9.8.
Okay. So this is actually colder than our fridges at home. Okay, again?
Minus 16.4.
Okay. Stirring, hopefully it will be able to freeze. Okay?
Minus 22.9.
So can you see some chemical reactions are extremely cold? They are what we call endothermic. Okay? They need heat to keep on going. Okay? And the last reading?
Minus 26.7.
Minus 26. And we know that water freezes at what temperature? At 0. So hopefully this has frozen to the pot. Okay? So we can see that this reaction is extremely cold, that actually freezes the water to the pot. Thank you very much, guys. Thanks for them. Okay? So guys, please excuse me a bit. Okay? I'm starting to feel a little bit slow, so I need to take some coffee. Okay? And we know what's the main ingredient for coffee? Yes, water. Hot water. That's the main ingredient. Okay? But guys, I do not have time to boil water. It will take about 4 or 5 minutes because it's a little bit cold, okay? But what I do have, I've got what we call hexagonal special water. Why is it special? Because you know water is what? H2O, okay? This one has got added oxygen, so it's H2O2. And we call that what? Hydrogen peroxide, okay? So I will use my special water, and remember this word special, because everything at Saibono is what? Special, okay? So this is my special water, okay? So guys, I do not take my coffee with sugar because sugar is what? It's bad for us, okay? And I cannot take milk because I am lactose intolerant. So I've got here my real black coffee, okay? So I'll add it inside, and please excuse me as I enjoy my coffee, okay? Okay, it's a bit hot, so I'll just put it on the side. Please remind me after the show to drink the coffee. Okay, guys, please don't forget. After the show, you can see it's still boiling. After the show, please remind me to drink that coffee. Okay? So guys, some of us, when we drink coffee, we use one of these cups because we like to have coffee on the go. Okay? Or you can add your tea, or your water, or your juice, or your soft drink. Okay? And after you're done drinking your beverage, what do you do with this cup? Where? Yes, please don't just say throw it away. Okay? Because I know some of us would like to just litter. So let us not become what? Litter bugs. Okay? So rather throw this in the bin, and if there's no bin around, keep it with you until you find a bin, or come to Saibono where we've got what we call a special liquid. Okay? So using our special liquid, hopefully I'll be able to dissolve my cup. Okay? So it's taking a bit of time, but you can see it sort of has a hole now. Okay? I think it's a bit cold, but what I've actually used here, but you can see there, it's actually dissolving. What I've used here is what most of the ladies should know, because they like to decorate what? Their nails. And if they don't like that color anymore, what do? They use what? Acetone. But they actually use what we call nail polish remover, because pure acetone will dry up your skin. Okay? So one of the ingredients of nail polish remover is acetone. So it is actually gets to break down your polymer. Okay? Remember your polystyrene cup is a polymer with 5% the polymer and 95% what? Air. So we are actually breaking the bonds and releasing the air. So that's why it seems like it is what? Dissolving. Okay? But it's not dissolving. And I'm sure some of you thought this was acid. Okay? So now I want to get a little bit controversial. Okay? Why do I want to get controversial? Because there's a certain company, hopefully no one works for it here. There's a certain company that has now said more than 200 days without load shedding. Okay? And we all know what that company is. But I do not trust them because any time is what? Tea time for them. Okay? They can just announce load shedding and usually it's at night. Okay? And when they announce load shedding, you want to cook now. It's at night, you don't have matches, you don't have a lighter. How are you going to start your fire? With rocks, okay? But you need to know certain types of rocks, okay? The one high in silica, okay? Your quartz. When you hit quartz against each other, produces that spark, and if you can capture that spark, you can have fire, okay? If it's during the day, it's nice. If you're going to magnify glass, you can use that if the sun is out, okay? What else can you use to start a fire? Sorry? Yes. That's another way, but what's the other one? I can see people are rubbing their hands. Some kids are rubbing their hands. Yes, two sticks rubbing together because you create what? Friction. And friction causes heat. So that's why when it's cold in winter, what do? We always rub our hands together, okay? To create a bit of warmth for our hands, okay? But inside Bono, we don't need all of that. We need our special spice and some glycerin, okay? What do we use glycerin for, guys? Okay? Glycerin is a moisturizer. And has anyone tasted glycerin before? Okay? Glycerin tastes sweet, okay? That's why in some countries it is used as a sweetener, okay? When I was growing up, I was not allowed to have any sweet things. But funny enough, I was given glycerin to moisturize my body. So this was my opportunity for me to get some sweetening inside my body. So every time they say I must moisturize my body, I was licking the palm of my hands to get what? Some sugar. Okay? So let's see what happens if we will be able to create fire by mixing glycerin and our special spice, okay? And this special spice actually is called potassium permanganate, okay? And potassium permanganate, guys, you can find at the pharmacy, okay? So sometimes the reaction happens, sometimes it doesn't happen, but if it doesn't happen, guys, you must not give up. You must have a little bit of what? Motivation, because that's what life is, okay? If things don't go well, you need a little bit of what? Motivation, okay? So with a little bit of motivation, hopefully we'll be able to start some fire, okay? Let's see if it does work. I think I need a bit more. There's a read. There it is. And what do they say when there's smoke? There should be what? Fire! Okay, so there we've got fire. So guys, use your special spice, which is your permanganate, and your glycerin. Guys, they are very dangerous. Okay, if you have them at home, make sure they're not next to each other, or else you'll burn down the house. Okay, this is just a classic example of what we call an exothermic reaction, but at the same time, it is part of combustion, which we call what? Your spontaneous combustion, because we do not need any external what? Source of heat. Okay, now I'll show you the power of explosive combustion, because combustion is divided into three: rapid, explosive, and spontaneous. Okay? So now I will do my explosive combustion. Remember, this can was never empty, it had what? Air. And air contains how many percent oxygen? The percentage of oxygen is how many? It cannot be 70. If it's 70, we'll all be dead. If it's 70, 78% is actually the nitrogen. Okay? 0.9% is argon, 0.1% is other gases, and 21% is the oxygen. Okay? It's 21%, not 78%. If it was 78%, I think most of us would be dead because you will naturally oxidize. Okay? So now let's see what happens when I bring a flame close by. In 3, 2, 1. Remember what I said? Some of these will start to make a bang and a pop. Okay? So you can see there's still some fire there. Okay? But that was a small bang, that was a small pop. Let's try using tins instead of what? Cans. Okay? So we'll start with the small one. But now instead of using methylated spirits, which was our fuel, I will be using one of these deodorant sprays. Okay? And guys, these things are also dangerous. That's why they put a fire dye on there. This is just to demonstrate it is highly flammable because this contains a propellant. And the name of the propellant is the gas that you can find here. A mixture of butane and propane, which is highly flammable. Okay? So let's start with the small one and let's see if it does work. So you just need a little bit, not too much. And let's see if we do create an explosion. In 3, 2, 1. Okay, I see a bit of fire there, but once it mixes with oxygen, hopefully it will pop. If it doesn't, we've got a medium-sized one. Okay? That's how I can do 3. Okay? Now let's try with this one. And let's see. Okay? In 3, 2, 1. That was a surprise. I was not expecting that. I was expecting that last band to be made by this one. No, this one. But you know what they say? Dynamite comes in small packages. Now let's see if this one will make a bigger pop than the medium one. Okay, the small one is a bit disappointing, but it's fine. Let us try with this one. Now let us see if we get a bigger head. So, again, in 3, 2, 1. Yeah, that was a bang. But what did you see coming out? You saw that flame. You saw that fire. Okay? That's what we call combustion. And the same combustion can be used where? In driving our cars. Because the petrol also inside the engine gets to what? Explodes. And what explodes, it pushes that distance down. So we want to replicate that in this water bottle. Okay? So my fuel will be what? Methanol. Guys, methanol is an alcohol, but they are highly what? Flammable. Okay? They are highly flammable. That is one of the properties of the alcohols. Okay? So remember, this was never empty, had what? Air. Okay? So your alcohols, guys, they turn into a vapor at a very, very low temperature. Okay? Around room temperature, they can turn into a vapor. And it is the vapor that is actually dangerous, that is highly flammable. Okay? So now, let's see what happens when we introduce air flame close to the mouth of the bottle. Okay? So in 3, 2, 1. Okay? So there, still going. Yes, there's still some fire. And you know one of the byproducts of burning air, hydrocarbon is what? It's water. So there's a bed of water there. A lot of water is formed there. Okay? Because it's a byproduct. Okay? So guys, remember the same principle of combustion, exploding gases can be used in where? In propelling what? Rockets to go into space. Okay? Back in the days, they used to use hydrogen, which is the fuel, and oxygen, which will be the oxidizer, to send rockets into space. Okay? But with technology, guys, they actually found a new way. Okay? Using what we call hybrid fuels. Okay? Hybrid fuels is a combination of fuels in different states of matter. Okay? How many states of matter are there, guys? Okay? You know of 3, but there's actually 4. 4? Yes. The 4th one is plasma. Okay? Plasma state, which means ionized gases. Okay? So, what we're going to create now is we're going to create our hybrid fuel using liquid, oxidizer, and our solid fuel. What is this? It's an ice cream stick or popsicle stick. Okay? And some of us, we throw this away in the bin after we've done what? Eating our ice cream. But some of us, what do we do with it? We chew on it. Yes. And once you chew on it, what happens? You get some small splinters. And where do those splinters go? In your stomach. stomach. And once they go into your stomach, I will show you what will happen. Okay? So there is my special salt, which we call potassium chlorate. Okay? It's turning into a liquid, into our liquid oxidizer. I add my ice cream stick. Okay? And there should be smoke coming out. But also look at the bottom. What can you see? Okay? Let's see how much energy this can give off. So you can see how much energy this can give off. Okay? So guys, whatever you do, do not chew on your ice cream stick, because now when it's time for you to sleep, you have so much energy that you are running circles around your parents when it's time to sleep. So please do not chew on that ice cream stick. And speaking about ice cream, guys, what happens when you eat too much sugar? What will happen to your teeth? They start becoming yellow, they start becoming rotten, okay? And you need to go to the dentist, and you cannot no longer use normal toothpaste, okay? Because that normal toothpaste cannot clean your teeth anymore. So you need an elephant's toothpaste, okay? You need an elephant's toothpaste. And to make our elephant's toothpaste, we need our trusted special water, okay? So here's my special water. And to make sure that your teeth are nice, bright, and white, we need some dishwashing liquid. If these can make your dishes to be clean, definitely to work wonders for your teeth. Okay? So we need some bit of it. Okay, mix it well. And obviously, I know, especially with the grown-ups, I know some of us have tried to taste dishwashing liquid when we were younger. Okay? And we know it doesn't taste nice. Okay? So, in order to give it a nice taste, we need some special sugar from Saibono. Okay? Our special sugar is called potassium iodide. Okay? This is just to give it a nice taste. Okay? Okay? So there is our toothpaste. Okay? Anyone with a toothbrush? Okay? So unfortunately, guys, no one has a toothbrush here, so you cannot try out this toothpaste. But please, next time when I come, be prepared with your toothbrushes. Okay? So guys, if you can see, some of these labels that are started here, they were making what? They were producing a lot of what? Heat, to a point that I'm starting to what? To sweat. Okay? So if I'm starting to sweat, that means I need to cool down. What can I use to cool myself down? Unfortunately, I don't have ice cream. But that's a good idea. Water, okay? I can use water to cool myself down. So I will do something very stupid and dangerous at the same time. I will attempt to burn my hand to try and prove that water can be used to cool things down or to cool ourselves down. So there's some water here. Unfortunately, guys, I cannot drink this water to prove that it is water because this is a bit dirty. Okay? They're filled with chemicals, so let me not take that chance. Okay? So I've added my dishwashing liquid and I've got a spray here. Okay? For some of us, we call this a toilet spray because it gets to be in the toilet. Okay? But this, guys, is not a toilet spray. This is an air freshener. You can use this spray anywhere in the house except for the toilet. Okay? Because whatever comes from the toilet mixes with this, doesn't give a nice smell, right? So you can use this anywhere in the house except for the toilet. Okay? So guys, this also contains a propellant. Okay? Remember our propellant is a mixture of what? Butane or propane. So that means it is what? Flammable. Okay? So first thing, need to protect my hand. Okay? So the dishwashing liquid is there to trap the butane. So hopefully I have enough. And let's see. if I'll be able to burn my hand. Hopefully, the fire department and the ambulances and the hospitals are close by, just in case I burn. Okay? My hand is fine. Okay? No. This is some side bono trickery. Okay, can I get 2 volunteers to try this out? Well, now because I'm bending my hand, now a lot of hands are coming up. Can I have the gentleman there prepared? Yes. Okay, can I have the lady? Okay, what's your name here? Asika? Are you ready? Okay, which hand do you use the most? Let's do the left one. It's the result of the fire. I'm joking. Okay, so what I want you to do is, you dip your left hand inside, okay, then you scoop the bubbles, you extend your arm far away from your face, and whatever you do not wave your hand. Because once you have that fire and wave your hand, what are you adding more? Oxygen. And once you add more oxygen, what happens to the fire? It can become bigger. So whatever you do, don't even look at it, just be like this. Okay? Yes. Okay? So, yes. Let it stay there for a couple of seconds. I'll tell you when to take it out. Okay? You can take it out. Scoop the bubbles. Okay, remember what I said? Extend your arm. Okay? In 3, 2, 1.
Fire! What do you see?
How was that? I want you to do the last one. What's your name? Sorry? FDA. Okay? Keep your hand inside. Remember, scoop the bubbles. Extend your arm. Okay? Extend your arm. Please do not wave it. Whatever you do not wave your arm. Okay? Okay? Those bubbles. Okay? Extend your arm. Okay, I was there. Okay? So, as you can see, my 2 volunteers did not beg, and I will explain. Thank you very much. Your name, sir? Ryan. Okay, Ryan, I want to try something out. But it's fine. Dip your hand. I've been trying to do it. My hand is fine. Make sure that you hold your... Yes. Okay. So guys, as you can see, my 2 volunteers, their hands did not beg. Okay, there was 2 explanations for that. 1, the fire was not there for a long time. The fire was very hot. I could actually feel it. And 2, because their hand was protected with water, what happened? The water is the one that absorbs what? The heat. So we say water has got a high specific heat capacity because it absorbs water, heat very, very slowly. That's it. Did you coat your hands properly? Are you sure? Yes. Don't worry about the mess. Do not wave your hands, please. How was that? It felt a bit warmer because the flame was there now a bit longer. Okay? But nothing happened to their hands because of the water protected their hands. Okay? That's why, guys, when we need to cool off, we use what? Water. Okay? But some of us will want to use something which I have here. Okay? Because it is much colder. Yes. Some of us like say, but there's something much colder. You can actually cool it down much quicker. Yes, you can cool it down much quicker. And if you drink it, you'll be in big trouble. You'll be in very, very big trouble. Okay? Can someone guess what is the temperature of this? -326. No, it won't be possible because absolute 0 is -273 degrees. So when we say absolute 0 means there is nothing colder than that afterwards. Okay? So it cannot be -300. Okay? but you have an idea that is extremely cold. This liquid nitrogen is so cold that it's actually boiling now. Okay? Why is it boiling? Because the vapor pressure and the atmospheric pressure are equal. Okay? So it's turning into a vapor. Okay? Another case, the temperature minus 196 degrees Celsius. Okay? If you decide to put your 2 fingers or your whole hand, okay, just for 5 seconds, what do you think will happen to it? It will freeze and your fingers will break off. Okay? Any volunteers? No. Okay? Let me try it myself. Okay? I said 5 seconds. That was barely a second. Okay? If I decide to leave that for 5 seconds, then I'll be in trouble. Okay? But I want to show you why it is recommended not to drink liquid nitrogen. Okay? Now, let us pretend this is your stomach. Okay? And your stomach, your internal temperature, what's your internal temperature? Body temperature? It's about what? 36.5. Yes. Okay? So, you decide that you are very hot, okay? And you cannot handle the heat anymore, and you decide to take a little bit of liquid nitrogen to cool yourself down, okay? Remember, your temperature is 36, 37. This is minus 196. So now, it is inside your stomach. What's happening to your stomach? Okay? Your stomach is getting what? It's getting bigger. Stomach is getting bigger. Stomach is getting bigger. Okay? Remember, 1 liter of liquid nitrogen can turn into 1,000 liters of gaseous nitrogen. So what will happen to your stomach? What will happen to your stomach? So guys, whatever you do, if you have liquid nitrogen around and you are feeling hot, do not try and drink it, or do not try to pour it from your body. Okay, you get frostbite. Okay? So for the last one, let's see what happens when extremely hot and extremely cold mix. Okay? So let me add lots and lots of liquid nitrogen. Okay? I'll put my liquid nitrogen in there. So I'll need something extremely hot for this. Look, not yet. Okay? Because I'm afraid you might just want to put your hand, then you put your whole hand inside and what happens? Yes. Okay? So let us not try that for now. Okay? But I will show you after we've mixed my extremely hot with my extremely cold, what will happen? Who has watched a movie called Terminator? Terminator 2. Okay? Okay? There's this scene where they actually pour liquid nitrogen on this other bad Terminator. I forgot what's the one. T-something. Okay? And what happened? He froze. Okay? Then they shot him, but then because the area around him was a bit warm, he started to cool down and came together. So it looked like that Terminator was actually made from what? Mercury. Okay? Mercury, which was a bit stable. Okay? Because remember, mercury is the only metal that is what? Liquid at room temperature. Okay? Let me add more because this is evaporating very, very quickly. Okay? So the guys in front will be getting a free shower. Okay? We're getting a free shower. I think my water is ready now. It's nice and hot. Yes? So 96 degrees Celsius, because clouded water will never get at 100 degrees. Okay? Because of the pressure. Okay, 96 degrees Celsius mixes with 109 minus 196. Let's see what happens in 3, 2, 1.
Moldag.
En medeleerders. Ek het die eer om vandag 'n fenominale juffrou te bedank vir haar diens en toewyding. Juffrou Marie, hierdie is 'n dubbele dankie aan juffrou. 'n Eerste dankie vir juffrou se jarelange diens en 'n tweede dankie dat juffrou teruggekom het om die Nuttiest weer te onderrig. Daar is min opvoeders wat hulle vak met soveel passie aanbied. Juffrou is 'n kenner op juffrou se vakgebied, maar beskik ook oor soveel kennis van ander vakke. Ek het in graad 10 die voorreg gehad om onder juffrou se hand kennis te maak met molsomme, Newton se wette en elektronaffiniteit. Juffrou se leidings
en wysheid is van onskatbare waarde. Juffrou neem jou resultaat as opvoeder ernstig op en is altyd voorberei en op juffrou se pos. Juffrou het 'n edel beroep gekies en volhard ten spyte van vele uitdagings. Juffrou is 'n eerbare persoon en het 'n goeie sin vir humor. Mede-personeel het groot agting en respek vir juffrou as persoon. Juffrou se opinie word hoog aangeslaan en daar is admirasie vir juffrou se kennis. Die geskenke wat ons nou aan juffrou gaan oorhandig, het elkeen 'n spesiale betekenis. Die Lori Oscar word aan juffrou toegeken want juffrou het supersterk status. Dit getuig van 'n baie sterk leier in 'n moeilike vakgebied en jare se ondervinding wat beslis gemis sal word. Die fotoraam bied spesiale herinneringe uit wat vullig vasgevang word. Dit dien ook as 'n terugblik op juffrou se suksesvolle loopbaan waarin juffrou vele leerders se harte aangeraak het. Die klok simboliseer juffrou se sintelikheid en die ure wat juffrou met liefde aan die vak gewy het. Juffrou is 'n ware dame en lyk altyd elegant en stylvol. Dankie en nogmaals dankie vir alles wat juffrou vir ons nodig beteken. Mag goedheid en guns juffrou volg al die dae van juffrou se lewe. Juffrou is geliefd